Welcome everyone, and thank you for joining us today. My name is Kara, and I'm with the LTAP Center here at ODOT, and I will be your host for this webinar. Today's webinar is leveraging abandoned railroad tunnels for bat conservation, and we're thrilled to have Joe Johnson as the presenter. Before we begin, I'd like to cover a few housekeeping items to ensure a smooth webinar experience for everyone. If you have any questions during the presentation, please use the questions panel on your screen. You can type the questions there and we'll address them during the Q&A session at the end. If you're experiencing technical difficulties or have any other issues, feel free to use the chat panel to communicate with our team, and we'll do our best to assist you. We'll also be sharing some useful resources throughout the webinar, which you can access via the handouts section, and a PDF copy is available for your reference of this webinar. Please note that this webinar is being recorded, and the recording will be made available to all registered attendees after the session. All right, with that out of the way, let's get started. It's my pleasure to hand it over to Joe Johnson. Joe, the virtual floor is yours.
Okay, thanks, Kara, and thanks for everybody for attending. I'm gonna go ahead and just mute my video. So, bye, kind of, in terms of visuals, and I'm just going to focus on presenting here to you. So again, the title of our talk today is Leveraging Abandoned Tunnels, Railroad Tunnels for Bat Conservation. I'm Joe Johnson. I'm an assistant professor of information technology at the University of Cincinnati, and I specialize in using technology to solve environmental problems such as animal conservation in the biodiversity crisis. So let's get started. First, I want to just make some acknowledgements. I like to start here because really funding for this work, without funding for this work, we would not be here today. And funding was provided by the Ohio Department of Transportation. And we really had phenomenal leadership from our project manager, Chris Starin, and great guidance from our ODOT Technical Advisory Committee, being Jennifer Spriggs, Matt Raymond, and Matt Perlick. Really without their guidance, leadership, navigation of the problems that occur whenever you're doing a complicated research project, we wouldn't have made it to this point, and we wouldn't be nearly as successful as we were. So a tremendous thanks to ODOT, to Chris, and to the rest of the TAC. Thanks also to the U.S. Fish and Wildlife Service and Ohio Department of Natural Resources for permits and support, and to graduate students that I've had in my research lab throughout the years, most recently Jeanette Perez Jimenez, Mateo Lewis, Levi Johnson, and Lucy Williams for all of the work in terms of both in the field as well as coming up with data analyses, conceptual ideas, and so forth. So here's just a brief overview of what we're going to talk about today. Just going to start with a very brief summarization of bats being imperiled wildlife. If you're not a bat person, some of this might be new to you. If you are a bat person, it's just going to be a quick review of some things you probably know. Quickly move in to establish the fact that bats live in some abandoned railroad tunnels. In our work on this project, which was primarily focused on identifying tunnels and tunnel features that were important to bats. In other words, what separates the some tunnels that we know bats live in from the ones that they are not found in, and how we can leverage these findings for conservation. Specifically, if we have an abandoned railroad tunnel that's not being put to any use, how could we make it look, so to speak, more like a tunnel that is valuable for bats in order to put that tunnel to work for animal conservation? And although I tend to be relatively long-winded, I do hope I leave plenty of time for questions. This is really something I'm passionate about. I tend to be a little bit nervous in presentations, so some of that excitement does not shine through, but this is really a topic that I love and would really be excited to talk about at length. So let's just jump right into this fact that bats are imperiled. Bats are imperiled for a lot of reasons, but here in the eastern half of North America, the primary threats to bats is a disease known as white nose syndrome. White nose syndrome is a fungal disease, and it's caused by a fungus that's not native to North America. We call that fungus Pseudogymnoascus destructans, or PD. PD was not known until it was first observed in the United States around Albany, New York in 2005, 2006. And one of the things that makes this fungus so unique is it's what we call a cold-loving fungus. It doesn't like temperatures to be as cold as possible, but it really thrives right around 13 degrees Celsius. And that temperature, 13 degrees C, is just a little bit warmer than the temperature that we find a lot of bats hibernating here in this part of the country. This is to say that this fungus that lives in caves just happens to prefer the same environments that many bats hibernate in. And this is just a really unfortunate confluence of circumstance because this fungus is a saprophyte. It will grow in wood, dead organic material, and a hibernating bat. Because from the fungus's perspective, it's just, lifeless organic material. During hibernation, bats have a complicated physiological downregulation of nearly all their bodily processes, including their immune system. And the fungus just exploits that. It grows in to the tissues of the bat, and it really initiates a cascade of physiological effects, including increasing what we call arousals from hibernation, the periods of times where bats appear to be sleeping during the winter months. They're not sleeping, they're hibernating, but they're not using any, they're not moving for months at a time or weeks at a time. They'll only breathe a couple of times a minute. Their heart will only beat for a couple of times a minute. And they'll go in this phase, this hibernation phase, for several weeks in order to conserve energy. And the fungus causes them to come out of that hibernation state more often than they otherwise would, causing them to burn through their fat reserves and ultimately die. And this fungus is spread throughout much of the United States and Canada since it first arrived with the aid of humans around 2006. And since that time, there's been some great research into a relatively sad topic, including this great summary from Tina Chang in 2021 that really summarized the state of affairs at that point. Somehow time flies, and it's now a couple years ago. So if we look at this red box here, what it's doing is summarizing for 5 different cave hibernating bat species at this time of publication what the scope of the threat of white nose syndrome is. That is, what % of the species geographic range do we know is also occupied by this disease-causing fungus, Pseudogymnoascus destructans. And for this first species here, Myotis septentrionalis, the northern long-eared bat, at the time of this publication, 79% of the range of this bat species was also occupied by the fungus, 36% for the little brown bat, 59% for the tricolored bat, a whopping 93% of the range of the Indiana bat, and 32%, just under a third of the range of the big brown bats. This next box identified what the severity of the threat is for each of those species. That is, what's the mortality rate in caves and mines where each of these species is present alongside this fungus, Pseudogymnoascus destructans. And it's 97 to 100% mortality for the northern long-eared bat. So put these two things together, 79% of the range of a species, up to 100% mortality, 97 to 100% mortality. This is a pretty bad situation. Similar story for the little brown bat, 96 to 100%. 90 to 100% for the tricolored, and then lower mortality rates for the Indiana and the big brown bat. And Chang and their colleagues said a bunch of other really notable things, but what I want to end on in this introduction to our work is that they quantified or they described the level of threat that the fungus presents to the status of each of these species. And for several species that we have here in Ohio, notably the northern long-eared bat, the little brown bat, and the tricolored bat, the threat to the status of these species is extreme. So these bats are incredibly imperiled by this disease that affects them during their winter hibernation. So it's not surprising that over the last couple of years, you may have seen headlines like this. Pardon the bias by my preferred news source, but it is what it is. You've probably seen headlines such as tricolored bats could become endangered, and they have been proposed to be endangered by the U.S. Fish and Wildlife Service due to the effects of this fungal disease. Similarly, the northern long-eared bat is now listed as endangered because of this fungal disease, and the little brown bat is currently under review. So in sum, bats here in Ohio are greatly imperiled by this fungal disease, and several species have been added to the endangered species list as a result, with another one currently under review. And this is where the Ohio Department of Transportation and railroad tunnels come into play. And when I first moved to Ohio around 2016, I was sort of primed by my past experience to meet this gentleman here, our project manager, Chris Starin. Somebody told me just by happenstance, oh, this guy Chris, he found a bunch of little brown bats in a railroad tunnel, and my ears really perked up when I heard this. I was really excited because at that time we didn't have very many bats in any of our known hibernacula here in Ohio because they had been decimated by this disease. So I was really eager to go out and see what he saw. And another thing that and something that I should also say is, these numbers of bats that we'll talk about in some of these railroad tunnels, it was unique to those railroad tunnels. This is just a graph from one of my students' works that he published recently. And you're just looking at blue dots here compared to orange dots. Blue dots are counts of little brown bats in a couple of railroad tunnels versus orange dots being in caves. And the numbers of bats that we were finding with Chris's help in some of these early explorations into railroad tunnels was just something we weren't seeing in any quote unquote natural habitat here in Ohio. That is to say, caves harbored very few bats, such as the little brown bats, but these railroad tunnels were these really unique habitats that seemed to be the only places these species were able to survive. And one thing that was incredibly disappointing is you get this immediate rush that, oh my goodness, this guy is telling me, sorry, Chris, this, now colleague is showing me this habitat that's completely unique. It's where these animals seem to be hanging on despite all of the conservation threats from this disease. But those bats are still at risk from the same old conservation threats that bats were facing pre-white nose syndrome. That is, they were vulnerable to humans in these railroad tunnels. So what I'm showing you here are the counts of tricolored bats on the left and little brown bats in the middle. In 2016, when Chris and some other colleagues first surveyed these habitats before I was on the scene, and we had, 9 tricolored bats, which for that species is a great count, and over 200 little brown bats, and that's a phenomenal count for today or then. It's unheard of then. And what they found the next year is that a lot of these bats were being shot with airsoft pellets. They found a large number of bats dead on the ground in the railroad tunnel, and they weren't killed by white nose syndrome. They were killed by being shot essentially with BB guns or some kind of air rifle. And this really set the stage for our current research. It really got us wondering a whole lot of different things. The first of these was, well, how many of these railroad tunnels are there in Ohio? And how many of them are hibernacula? Because if we have this one site that seems to be a refuge from a disease, but still vulnerable to the human population, we need to find as many of these as humanly possible so that we can manage them, so that we can protect the bats that are there. And we also wanted to know with our second research question, what is it about the sites that we were finding bats in that made them special? What are the characteristics of a railroad tunnel hibernaculum that sets it apart from, say, any old railroad tunnel? Or were they all great for bats? We really wanted to know the answers to these 2 questions. And so this is where our research comes in. So how did we tackle these questions? Well, first, we needed to know how many of these railroad tunnels are there. And this was a great research question for a guy like me. I'm just a guy of average intelligence who really loves bats and loves a mystery. And this was a simple mystery, because for something human-made, and you would think hard to miss, a railroad tunnel, they're kind of lost structures. There was no database, at least to any of our knowledge, and there still isn't until we made one, a database of all the abandoned railroad tunnels in Ohio. We had to go out and quote unquote find them. And so how do you find an abandoned railroad tunnel? Well, we did a lot of different things. We kind of just took as many approaches as we could find in order to just gobble up or collect as many as we could. We searched hobbyist websites. There are a lot of those. People just dedicated to abandoned structures online. We used digitized maps, such as this old USGS topographical map here. I don't know if you can see my cursor, but if you can see the major road on the top of the screen, it comes across a intersection where to the south it proceeds as an unimproved road, that dashed line. That dashed line eventually meets up with the old railroad grade, and you go a little bit east along that old railroad grade and you see a little sign that says tunnel. We literally just scoured old topographical maps looking for these tunnels, but they're not all noted on these topographical maps. So we used other spatial data sets. We used digital elevation models. We use satellite photos. Here's just a simple satellite photo with a black line laid over it, which is just a digital layer in GIS for an abandoned railroad line. And what we did is we looked for instances such as this. We would follow these abandoned railroad lines visually on GIS and just look for instances where it goes under a hill. Or if you're looking at a digital elevation model, you can see where that railroad line crosses a steep change in topography. And again, you don't have to be, you don't have to have a great amount of experience to understand railroad tunnels don't go over really steep hills up and down, they go through them. And so once we found evidence of these railroad tunnels, even more fun could occur. And I will say that this was actually a great part of this project, is just scouring the internet, looking at old maps, looking at the way the world or Ohio used to be, and trying to find these old structures. It's a really cool way to spend your time. But an even better way to spend your time is to go into the field and see if there's bats in there. So we conducted winter surveys in these tunnels. Once we found them, we would ground a truth that they still exist. We would figure out who owns the tunnel, who could give us legal permission to access them. And we would go inside those tunnels between December 15 and March 15, sort of the heart of the winter hibernation period. And we would conduct surveys for bats. We would just walk through, or in this case, if you look real closely, you can tell that we're floating through. This is a fully flooded site, so we have to kayak through the whole thing. And we're collecting just the number of animals of each bat species that are present in the site. And we're also collecting a suite of habitat data. We're trying to measure the tunnels in as many ways as possible. And I'm not really going to go into great lengths in this aspect or this really boring text-heavy slide, but this is really to say that we approached this research question, the second research question of what makes a tunnel suitable habitat. We approached it from a naive perspective. This question of why bats use some railroad tunnels hasn't been well explored in the literature, so we just assumed that we know nothing, and we collected every variable we could. We put temperature data loggers in the site, and we summarized the temperatures that we recorded during the winter a variety of ways: the minimum, the maximum, the average. We measured the physical structure itself, the height of the tunnel, the width of the tunnel, the length of the tunnel, how many entrances there were, because sometimes these tunnels get buried or sealed off or partially collapse. And then we measured the landscape surrounding it using GIS. And what we did is we used a machine learning approach called random forests to take all of these variables and help us identify the most important variables in predicting the counts of different bat species. And I'll say right now that we focus on little brown bats, tricolored bats, and big brown bats, because those are the species that we were able to find frequently enough to analyze statistically. So, if you just look at this picture here on the right, or this collage, hopefully you can get an appreciation of what we're trying to do. A railroad tunnel is not a railroad tunnel, is not a railroad tunnel, right? That is to say they're all unique snowflakes. They all look different. They're constructed differently. They were made at different times of year. They have different internal characteristics, different states of disrepair. Some of them were sealed off differently or buried. And each of these little wrinkles, when you combine all those different variables together, makes each tunnel unique in a different way. And we use a machine learning approach to help us really narrow in on what variables are most important, So we could do sort of the normal statistical approach in wildlife work is create something like a generalized linear mixed model in order to understand what effects those variables have on the number of little brown bats, number of tricolored bats, and number of big brown bats. So all a generalized linear mixed model is it something similar to an ANOVA, which you might be familiar with, but it's got more relaxed assumptions, works well with messy data, such as bat counts. And what we do is we took the top 5 variables identified in our machine learning approach, and we simply put those top 5 variables through a model selection process. That is, we created all the possible combinations of those 5 variables for each species, and then we let the model selection process using Akaike information criteria, or AIC, in order to help us say, these are now the 1 or 2 variables that best explain variation in the data set. So what did we find? Well, we located 50 railroad tunnels in Ohio using those means that I mentioned earlier. Now, I don't know if you had any expectations for what this number would be over the last 15 minutes, but this was a lot more than I thought. I did not expect to find 50. I expected to maybe find 20. So this was really exciting. Starts to get less exciting, but still pretty good. We were able to visit 48 of those 50. One landowner, actually a golf course, would not return my phone calls. So if anyone is an avid golfer in Central Ohio, send me an email. I need an in at a particular golf course that I won't name. That golf course wouldn't let me there, and another landowner wouldn't let me on as well on private property. So our total sample size of 50 gets zipped down to 48. We visited all 48, and we start deleting more tunnels from our list. 4 or 8% of our 48 had collapsed. Just over time, fell apart. 1 had been filled in intentionally. Another one, we couldn't tell what the story was there. It had either collapsed, it had been buried too fully and we couldn't find where it was, or it was filled in. Just couldn't figure out the history of that site, but it was no longer accessible to bats or humans. An additional tunnel was converted into a tourist destination. It's a little bit of a haunted house of sorts. Another tunnel was being actively used as a landfill. So what you have here is you've got 50, a total number of sites. And, I'm certain that over the course of the next couple of years, maybe I'll find 1 or 2 more because it's hard to find all of them. But you have a total of 50, give or take a couple, of the total amount of habitat in the whole state. And what you see is the number of sites that are actually accessible to bats becomes pretty small pretty fast. You lose a fifth of that, and you get down to 40 sites. So it's still more than I expected, but it starts to become rare. And it starts to, make me sweat a little bit when we start thinking about that these sites are valuable, but they're also rare and they're also going away. They get converted for other purposes. They fall into disrepair. They become used as landfills. So they're rare and they're at risk, right? And so this is kind of an important part of the story that we'll get to later. But for now, let's go to talk about what bats we found there. So we surveyed these 40 tunnels a total of 167 times over 4 winters. You just don't go into a site once on 1 year and say that you know it all. Bats are complicated creatures, and so sometimes it could be that you surveyed it too early in the year, too late in the year, or maybe the populations are still recovering from white nose syndrome. So we took a couple of years before we were able to feel confident in our results. And so it's 167 surveys over 40 tunnels. So there's a lot of data. Of those 167 surveys of 40 tunnels, we found that 65%, right? So this is kind of a jaw drop number for me. 65% of these sites were used by big brown bats, with the total number of bats in those sites ranging from 1 to 146. So the majority of abandoned railroad tunnels in Ohio are hibernacula. Big brown bats, but that's still an important number, right? There's still important resources for bats. And as we talk about some of our rarer bats, our percent goes down, but the importance, I think, goes up. 12 of our tunnels, that's a third, were occupied by little brown bats or little brown myotis. So that's one of the species under extreme threat of white nose syndrome and currently under review by the U.S. Fish and Wildlife Service. And the number of little brown bats occupying these sites ranges from 1 to 806. 806 is a lot of little brown bats in 2024, a lot. So if you're not familiar with bats, maybe that number doesn't strike you as like an, oh my goodness, but you know, we get out of that tunnel in the winter after that survey and it's just ecstatic over those numbers. So this is the most important hibernacula for this species in the whole state. So it's a very important resource. And almost a third of railroad tunnels are occupied by some of these animals. So that's really important for starters. 11 or 28% of sites were occupied by tricolored bats, with counts ranging from 1 to 49. And this is one of those species that has been currently proposed, or the U.S. Fish and Wildlife Service proposed that it should be added to the endangered species list as endangered, and allegedly will be any day now. I don't speak for the service, but that's my understanding of the situation. And 5% of sites are occupied by the northern long-eared bat. That is a species that is currently listed as federally endangered. We've only ever seen one bat, but as I'll talk later on, we think this is an underestimate. And an additional site, one site, was occupied by silver-haired bats, which is a really rare find in the winter. So that's some broad level overview. Let's talk about the results of some of our models and what makes some of these sites important for bats. So let me start by saying our random forest, our machine learning model that took all of our variables and put it through the meat grinder and said, well, what's most important here? That was able to explain 75% of the variance in bat count. So it's a pretty good model. It doesn't explain it all by any means, but for wildlife work, that's pretty good. And what you're looking at here is just a list of variables on the x-axis and importance on the y-axis. Here, importance is what you would call an arbitrary. It's a variable with arbitrary units. It is just to say what the value is of that variable. That is, if you took that variable out, what does the model sacrifice? And what you can see here is the most important variables in this random forest model are far and away the length of the railroad tunnel has a very large importance of the model. So does the range of temperatures during the winter. So that is simply the maximum minus the minimum temperature, right? What is the total variation that we see in that tunnel during the course of the winter? This is a number that's very important for bats. Simply put, bats don't like, most bats don't like highly variable environments to hibernate in. They like to know what they're signing up for. The minimum temperature was also important. The area, the total, what we call total portal area, that is the cumulative size of entrances to the tunnels. Remember, we looked at that image earlier showing that some of the tunnels have been partially or completely sealed and buried. We calculated the area that was open, i.e. subject to air flowing through the site, changing the temperature during the winter, and the average temperature. So we ran this random forest model. You can see that we see two variables right away, one structural, one temperature, that really drive a ton of variation in the system, followed by a pretty steep decline in variable importance. But we still took these top 5 variables and we created a suite of generalized linear models and let that process sort of guide us in terms of what variables explain bat counts. And what we found in that process is that the winter counts of little brown bats or little brown myotis were greater at longer tunnels than those with less temperature variability. And these counts actually increased over time. So let me just take a second and describe this. What you saw in the previous graph is just a list of variables that are important, but it doesn't really tell you what each one of those variables means. It just says length is important. Temperature range is important, but it doesn't say, well, what is important about it? Do they like longer tunnels? Do they like shorter tunnels? And that's what this generalized linear model can quantify for us. And that's what you're seeing in this kind of complicated panel on the right. So what you're seeing here on the y-axis of each one of these 3 panels are the number of little brown bats counted at a site. And you can see the gray bars on the top of each facet are just quartiles of temperature range. So it's just taking a large data set, that is the variability in temperature in a site. And it's just simplifying in terms of the first 25%, the second, and so on. And what you're seeing here on the left is simply less variable sites, those with an only 3-degree range of temperature variation during the winter, and more variable sites on the right, those with almost a 24-degree swing in temperature on the inside of the tunnel during winter. Now notice the difference in the y-axis between that panel on the right and the panel on the left. Here we're talking about counts ranging from greater than 80 bats to sites with the maximum number of 2 bats. So this should really show you right away that the less variable a tunnel is in terms of its temperature, the more bats you see. And then also what you're seeing with the individual lines in each facet is the impact that tunnel length has, with the blue lines representing longer tunnels and the red lines representing shorter tunnels. And you can really barely see the red lines in each one of these facets, right? These short tunnels were simply never used by little brown bats, and long tunnels, especially long tunnels with a small range of temperatures during the winter, are where we find the greatest number of little brown bats in winter. Let's do the same. Oh, actually, before we do the same thing for tricolored bats, I just want to mention that if you think back to that random forest plot, you saw that we had several different ways to quantify temperature. We had range, minimum, maximum. These different variables really tell you the same thing in a different way for these railroad tunnels. That is, temperatures with a larger range of temperatures during the winter. So that's what you see on the x-axis of this simple linear regression here. It goes from tunnels with almost no variation to really large swings in temperature during the winter, right? Tunnels that tend to be more variable during winter tend to have lower minimum temperatures. This makes sense, right? If it's more variable, that simply means it's more exposed to the elements during winter, and it gets to be extremely cold in some of those sites. Similarly, if we change this graph to be maximum temperature, you would see that tunnels with a wide range of temperatures during winter also end up experiencing the highest temperatures during the winter. And this kind of makes sense in biology. Most bats don't like these extreme swings during winter, although there's an exception that we'll get to at the end. So let's do this same process for tricolored bats. Different species have different winter ecologies, different physiologies, and so forth. And so we need to analyze the data for each species separately, right? We just can't say that a bat is a bat. So when we look at all random forest models for tricolored bats, we see that we were able to explain 62% of the variance in counts. So this is a moderately good model, not as good as what we found for the little brown bats, but still useful. Just doesn't explain as much of the data. This species is simply harder to understand. And so what are the variables that the random forest model told us were most important? Well, what do you know? Similar cast of characters, tunnel length, the range of temperatures during the winter, the minimum and maximum temperature, which are very similar to range in the total portal area. So we took these 5 variables again, and we said, well, what is the most parsimonious, statistical model for this to help us predict bat counts? And we found something similar but slightly different to little brown bats, right? Here we saw that winter counts of tricolored bats were largest in the tunnels with a smaller range of winter temperatures. So this part of the story is the same to little brown bats. These two species do not like variable environments during winter. The difference between the two species is simply that tunnel length mattered for little brown bats, but it did not matter for tricolored. So you could have a short tunnel with a lot of tricolored bats and a long tunnel with a lot of tricolored bats. That was not the same in our data set for little browns. So similar stories in terms of the temperature, but in terms of the physical environment, slightly different between these two critters. Finally, let's look at big brown bats. Winter counts of big brown bats were explained by some slightly different variables. The maximum temperature, the latitude, the longitude, the tunnel length, and the range of temperatures. And this model was able to explain 79% of the variance in the model. When we take these 5 variables and we put them into our generalized linear model selection process, what we found is that the winter counts of big brown bats were best explained and were greatest, interestingly, at tunnels with the most variable temperatures. Totally different story than the last 2 species. And from the perspective of somebody who goes to these tunnels every winter, this makes perfect sense. You do not find large populations of little brown bats and tricolored bats in the same railroad tunnels that you find the largest populations of big brown bats. Big brown bats are found in these very variable environments. In fact, we will sometimes find big brown bats in active railroad tunnels. These bats hibernate in buildings. These bats hibernate in cliff lines. These bats are tough in a way that little brown bats and tricolored bats just aren't as cold hardy, let's say. And so we see a different relationship between temperature with this species than we did the previous 2. So these are cool stories. One thing that I mentioned before is that we've only ever found the greatest number of northern long-eared bats we've ever seen in a railroad tunnel is 1. But I want to say that our counts in our research, as good as it is, underestimates the value of these tunnels for bats. Anyone who's done some of these surveys with me in the winter will know that I'm often listening in these tunnels because you can hear bats behind the wall in places where you can't see them. And so what you see on this photo on the right is a thermal camera positioned and aimed at this red box right on the top of that image. And that red box, you can see the actual video footage from the thermal camera here. What you're really going to be paying attention to is you can sort of see the outline of this alcove in the railroad tunnel. And in these alcoves, there'll often be cracks and spaces that go into voids of the wall where we can't see. And here on the thermal videos, we often see bats coming in and out all winter long. So here's one of these videos. And it's just simple, right? You just see this bat crawling out of this crack in the wall in the middle of the winter. It's warm, the environment is cold, and after it warms up for a little bit, it just takes off. And if that seems like, I don't know if I believe that, right? The reverse is true, right? We see animals coming in to these crevices. So here's an animal flying out of nowhere and then just crawling into that space and disappearing. So I feel that I know that we have some pretty good data that talk about the value of these structures for conservation, but I will say that we're actually underselling them when we talk about those large percentages of sites that are used in the large counts that we see in some of these tunnels. They're actually underrepresenting the value of these really unique habitats. All right, so that's a great story about bats. How do we use that, Joe? Right? How do we leverage these data for conservation? Well, I think the first thing that I would like to say is that tunnels with tricolored and/or little brown bats hibernating in them should be gated. And 3 tunnels have to date, thanks to the Ohio Department of Transportation, who funds and orchestrates this gating work. And so why do I say they should be gated? Well, let's look at the data. Remember this story I told you earlier of in 2016, just before I had met Chris, he had surveyed this site where they had over 200 bats one winter, and then the next winter they had found a whole bunch dead, and it was down to about 40 individuals. The red line in this graph represents it being gated after that second winter of data. And look what happens. The counts immediately rebound. They went from about 50 bats to about 150 bats in one winter. And little brown bats and these are just little browns, they only have 1 young a year. And these tunnels, this is not just like the effect of, these were all females, they all went out to their summer roosts, they all had 1 pup that survived and all came back. That's not what happened, right? This is increasing faster than annual reproduction. Once this site became viable again for these species, they immediately came in and took refuge, and the numbers have been growing ever since. Sure, this is an N of 1, but this is, in my opinion, unarguably a valuable, old school, tried and true conservation method for the species. And it's not just the little brown bats that responded well at this site to gating. This is the data for tricolored bats. Yes, it went down to 0 after these animals had been shot up. immediately rebounded and have remained high, although year after year quite variable since. This year after year variability is partly why our models don't perform as well. Tricolored bats have smaller counts with more noise, but it's clear that gating did not hurt this species. And I think when you combine the fact that people shot them till they can't get in now, and these bats have been rebounding well, it's clear evidence that gating has been a successful conservation measure at this site. And it's not just one site, right? Here's another cave. So this is, or sorry, railroad tunnel. This tunnel is completely flooded. When we first found it and surveyed it in the winter of 2020 to 2021, there was over 200 bats. At that time, it was now our largest known site. It was gated the following summer, sort of a epic amount of work by the Department of Transportation to gate this site almost immediately after finding it and documenting its importance. And it's clear that this definitely did no harm. It almost tripled in size after it was first discovered, right? It definitely more than doubled and has been growing ever since. And this is critical because even though this site is completely flooded, when you, it sounds like I'm making this stuff up. Here's Chris. When you kayak through this site, you see that there are messages in bottles inside this tunnel. And if you grab that message in a bottle and you open it up, I block the names of the people to protect their identities. It says so-and-so and so-and-so canoed through the tunnel on August 20th, 2011. This is during what's called the swarming period for bats. This is when they're choosing where they want to hibernate. This is when they're copulating. This is a critical point in their annual cycle. And here you have people kayaking through the tunnel, creating a huge disturbance. Now, these people didn't mean poorly. It seemed like a fun idea. I have fun when I do it. I don't blame them. But for a species that's under review by the U.S. Fish and Wildlife Service for federal listing, this represents a clear threat that gating has stopped. Just similar graph showing that tricolored bats also responded favorably to gating at these sites. So gating has clearly be effective for conservation. And you really don't have to go to these lengths to prove it. But again, I'll prove it to you. These tunnels are visited all the time. We have cellular trail cams at these sites, and look at the dates on these. November 7th, November 22, December 29, March 24. These are all dates during bats' winter hibernation where people are showing up to go have fun, right? To go explore, and they're not trying to hurt bats probably, but were this gate not to be there, they actually would go in and they would harm bats. And really everybody from all walks of life thinks that these tunnels are cool. And we see people show up at them all the time. They are just attractive nuisances, I guess. And bats love them and people love them. And unfortunately, when you have that juxtaposition, sometimes you need to do something like gating in order to protect the resource. How else can we leverage these data? Well, tunnels with tricolored bats and little brown bats should be gated, like we said, but also little or unused tunnels, especially long tunnels for little brown bats, can be gated and they could be modified to stabilize internal temperatures and increase bat counts. So remember I said that both little brown bats and tricolored bats, they prefer the tunnels with the smallest temperature range during winter. Well, it's pretty simple. In order to minimize the range of temperatures during the winter, you just partially, but not completely, bury this tunnel. So you can modify it by stacking up earth, like the Department of Transportation did here, right? And this is just a kind of a proof of this concept. Here you can see as total portal area increases, the range of winter temperature increases as well. So you want to be down on the left side of this graph. You want to have a small-ish portal area in order to restrict airflow, although you don't want to stop it, in order to have a stable thermal environment. And when we do that, like we did at this railroad tunnel here in Ohio, you see, right away, bats get kind of freaked out. That first winter, when it goes from this to this, the animals show up and they're just like, what? But within a year or two, they come back in equal numbers, and then they start increasing relatively rapidly. And so this has been a positive way that we can take this information about the features that make some tunnels valuable and spin it forward into ways that we can make habitat more suitable where it is currently not present. And in this white nose syndrome era, where we have so many federally listed species, so many species that need our help, this is pretty exciting stuff to be able to do good for these critters. So in conclusion, abandoned tunnels are extensively used as hibernacula by bats in Ohio when quote unquote natural habitats like caves are not. So these are used extensively and they're critical. In fact, the overwhelming majority of little brown bats are known to overwinter, and that are known to overwinter in Ohio rely on these tunnels. I mean, I think last winter and all the sites that we surveyed, we maybe found like less than 10 little brown bats in natural sites, whereas it's well over 1,000 in railroad tunnels. So these sites are used extensively, and for certain sites, they're quite critical, right? And less important tunnels can actually be modified to improve their conditions. And this part I think is obvious, but maybe hard to appreciate. You know, they are, after all, human structures. And so they were built and they were modified, and some were modified in certain ways that made them suitable for bats, whereas others weren't. That is, they were sealed up to some extent. And then I like to joke somebody needed a place to drink beer, and so they dug out an entrance so that people could get in, but then the bats in the air got in too. And that's what made these sites so suitable. And we can recreate that at the rest of these sites that aren't used. So we can really leverage these results, I think, to do a lot of good for bat conservation. All right. That was a very lengthy presentation. I hope that you found it insightful. I hope that you caught the beginning. Again, this work would not be possible without funding by the Ohio, or from the Ohio Department of Transportation, without the guidance of our project manager, Chris Aaron, and the advice and guidance of our technical advisory committee, Jennifer Spriggs, Matt Perlich, and Matt Raymond. So with that, I think I would like to open the floor to any questions.
Fantastic. Thank you, Joe. That was a wonderful presentation. I am watching the question area right now. We don't actually have any coming in just yet. Oh,
My
here we
favorite.
go. You what?
That's my favorite when there's no questions.
Yeah. Right. We've got a couple. First question, how close are we to implementing some of these findings for bat preservation?
Yeah, so here in Ohio, actually, and you know, maybe you wrote this before that end, but we are doing some of this. And by we, I mean Ohio Department of Transportation. So I actually, you know, I shouldn't say we, they. Ohio Department of Transportation has gated several of these sites with some help from other agencies in the state. And also they have been modifying these sites to make at least one of these railroad tunnels have less temperature variability in the winter than it did before, in order to make it more suitable for tricolored bats and little brown bats. And this past winter, we really saw the numbers go up to a greater extent than we had in the past. And so we are at the beginning stages of it, I would say. There's been a couple of sites gated for a few years now, but really I think that this work has been implemented and translated to some extent, and I like to think that it's going to be continued and carried on in the future.
Wonderful, thank you. Okay, our next question. Oh, we have great presentation. And any insight on humidity? The person says they may have missed that.
Yeah, so I kind of glossed over that because without taking up the rest of our time, humidity is a little bit of a vexing variable. There are really involved ways to measure humidity accurately, but we had so many tunnels and so many of them are so open to the public that we could not do that at scale for all of our sites. And we couldn't do that at scale for enough sites to accurately measure humidity. So we did not do that. One thing that I would like to though. One thing that I do think a future publication of this work will entail is a quantification of the amount of water in these sites. And I've got that feedback on a couple of presentations, some real simple common sense ways to measure the amount of water, because when we look at our most important sites, they always have large flooded areas. So areas where you either need chest waders or in this case, a kayak to get through the whole thing. And I think there's two benefits of that. One, if the site isn't gated, it's hard for people to get into. And then two, that temperature not only provides humidity or moisture into the air, but it also stabilizes the temperature. Water has that awesome effect of really capturing some of that variability and tamping it down in the air temperature. And so water has such a positive role in these sites, and it's not well captured in our current analysis, but I think a publication that will be essential.
Wonderful, thank you. All right, next questions. Does Ohio DOT hold conservation easements, or what mechanism is in place to allow modification or gating on private property?
Yeah, so I'll be curious to know if the available version of this webinar, like, maybe deletes this part, because I can't speak for the Department of Transportation, but the answer is yes. There are conservation easements that are organized, and I'm not sure if the word would be owned, held by Ohio Department of Transportation. That's less my work and it's more Department of Transportation's, but the answer is yes. So they do have private and they do have public partners. So some of the important habitats, railroad tunnels, mentioned in this presentation, some of them are private with conservation easements between ODOT and the private landowner, and it's a great relationship. And in other instances, it is a relationship between a public entity, right, a state agency, and ODOT. And in both of those cases, it's been a great example of working together.
Wonderful, thank you. Okay, we have a really good question. As an ODOT employee, how can we get involved?
So I mean, that's kind of an interesting one, because from my actual moment on this project, the research side ends, and now it's handing it over to the folks at ODOT to keep it going. And so there's a couple of things. So we've mentioned a couple of the people who really made this work possible: Chris Starin, the Mats, and really supporting them is huge, right? And so you could always reach out to them, sorry guys, and ask if you could be part of these surveys. If you know of railroad tunnels on your district or under your purview, or if you just happen to come across them, communicating them to those individuals is essential, because although I say I found all of them, I know I didn't. There's still more out there to be discovered, and it's gonna be often organic how they're found. So folks like you working at ODOT who find it and communicate it up the ladder, but then also think about the ways in which this story is not unique. And I mean, it is in some ways, but it's not in others. Imperiled bats use bridges. Imperiled bats use culverts, right? There are lots of ways to leverage transportation structures in positive ways for bats that isn't a conflict, and it's more of a celebrating the ways in which ODOT can contribute to the solution. And I think that there's some great people doing some of that work here at ODOT. And I think, brainstorming those and coming up with new ones is key, but also reaching out to those folks directly and seeing how you can support them is also an important way, or important thing to do.
Great, thank you, Joe. All right, next question. What about studying the use of abandoned underground mines and creating openings on the ground for the bats to get into the mines? So I guess an idea.
Yeah. So there is some of that. And so mines are a tricky one here in Ohio. So there's a couple of very well-known limestone mines. Some of them are surveyed annually by state agencies and myself. And the ones that we're at least able to survey, those populations have declined to pretty much zero and not rebounded post-white nose. And then, unfortunately, abandoned coal mines are tough, because many of them are unsafe to survey. And so there's a complicated answer to this question. There are some projects. There's a publication by myself and some colleagues from the state of Pennsylvania where we did modify sandstone and limestone mines in order to make the temperatures more suitable. So you're onto something exactly, but you need to have the right context. You need to have an environment that's, physically stable and not going to collapse. You need to have a partner. In that case, we worked with a natural resource extraction company, CNX Resources, that helped us actually modify the entrances to those sites. And we did find increased species diversity and the number of bats increased following management of those sites. But that's like a tricky thing to do. You have to really understand airflow, the topography, the site. You have a lot of pieces in place, but it's definitely a thing that people in some cases are doing, although some folks are a little wary of it, like everything in science, not everyone agrees. But then abandoned coal mines are another story entirely. In some cases, they're sealed for environmental and human safety. And in other cases, we can't even survey to go in and know what's underground. And so here in Ohio, we have thousands of mines that we actually know next to nothing about. And that is a source of frustration. And so if anyone here at ODOT has any, rovers, drones, etc., that can start to navigate some of these abandoned mines, please give me a call. Love to be part of that. Safety in some of these structures really keeps us from sort of even knowing if they're already good habitat.
Fantastic. All right. Let's see here. Have you had any discussions with the USFWS where mitigation for, say, tree cutting could be leveraged for gating enhanced tunnels as mitigation? And then we have a thank you, and it was a very interesting presentation.
So that, I think what I would say is maybe direct those comments to the colleagues at ODOT, especially Chris Starin. That's very much, I think, that's very much the inspiration behind this work from ODOT's perspective. And I mean, I can't speak for them, but I think I'm going to get that right, is that of course ODOT wants to do the right thing environmentally, but there sometimes needs to be a good justification for doing it financially. And there is a mitigation angle to this. It's not my aspect of the project. I don't really fully get mitigation. And so I would screw it up if I tried to mention it, but that is part of the work here. And ODOT is getting, or at least is planning to, hoping to get some of that benefit for the good work that they do here, because, a lot of money, a lot of labor, a lot of good work has produced these results. And they're, in my opinion, is a perfect justification to continue to do that through a mitigation process. But that's a little bit outside my wheelhouse. I'm just a guy who uses technology to study bats. But I agree with you, and so do the folks who funded and managed this work.
Wonderful. Okay. We do have a comment. Someone says that ODOT has a database of the location of the abandoned underground mines.
That's correct. There's a fantastic mine viewer for all the mines that we can go up to and go in if you're daring. Please don't go into abandoned coal mines.
Okay. Well, let's see here. Well, I'm not seeing any more questions. We do have many accolades. Great presentation. Thank you, Joe. And thank you everyone for joining us today. On behalf of LTAP and ODOT, I'd like to thank Joe once again for sharing your valuable experience and knowledge with us. As mentioned earlier, the recording of the webinar will be shared with all registered attendees, and you can find those additional resources in the handout section if you would like to take advantage of that. Thank you for attending, and we hope you found this webinar informative and engaging. Have a wonderful rest of your day.
Thanks, everyone.